we can send that out after the case. Rob has also, if he hasn't yet, he will be populating in the chats, I believe, Rob, the slide deck. Is that correct?
Yeah, I already forgot about that.
Yep. So we're going to be putting that in the chat, so you can download that at your leisure. You'll have access to that. And as always, feel free. Rob's contact information will be at the end of the slide, so feel free to reach out to us. You can also visit our website at 4mobilesafety.com. That's the number 4mobilesafety.com, where all of this and much more information is available to you. If we wait just maybe a couple more minutes here, we did promise we'll keep today's webinar relatively brief, probably about 30 to 40 minutes, closer to 40 if we have, if we do have some questions at the end. The end of our slide deck does have just, a lot of images, of applicational situations, different, our cameras and things on different solutions. So good opportunity for questions at that point too. But if you have something that comes up in the meantime, feel free to populate it in the chat. We will be monitoring that and we'll answer them as quickly as we can. All right, very good. Thank you, Rob, for doing that. So you can find the slide deck in the chat, everyone. You can download that if you'd like. All right, so we're going to go ahead and get started. I would like to introduce our speaker. His name is Rob Rascosi. And in 1999, Rob started Advanced Industrial Marketing, who I am a happy team member of, AIM for short, AIM, as a manufacturer's representative firm serving industries across the Midwest. He graduated from Purdue University with an electrical engineering degree, and then partnering with companies who were seeking a technical skilled rep firm, he helped bring their products to market. And during the last 20 years, AIM has expanded across the U.S. with offices in Atlanta, Chicago, Detroit, and Indianapolis. Over the last 7 years, Rob has studied mobile equipment safety and is a well-respected resource to many industries. He has been invited to speak at the Steel Industry National Organization, the Pulp and Paper Safety Committee, the National Slag Association National Convention, and the Department of Labor in Washington. To date, he still prides himself on understanding our partners' technical advantages and how to apply them to our customers' unique applications. And today he looks forward to spending the next 40 minutes introducing technology that can help improve the safety and efficiency of your material handling operations. So without further ado, we'll hand it off to Rob. And thank you again for joining us, everyone.
All right, everybody. Thanks for joining. As Andrew stated, we're happy for you to spend a few minutes with us talking about how to improve the mobile equipment safety and efficiency of your operations. Without a doubt, material handling is one of the most dangerous portions in any industrial facility. It's consistently rated as one of the top OSHA violations. And depending on the industry, it is usually in the top 5 of most dangerous jobs in a facility. And in some cases, it's the leading cause of fatalities in many different industries. So unfortunately, material handling is a very, very dangerous part of your operation. But fortunately, over the last several years, there's been an increasingly amount of technology made available that's been applied to the forklifts and the machines that are present in many industrial facilities. So what we're going to do for the next probably 30 minutes or 20 minutes, depending on how we go here, is I'm going to introduce what we see out there as the leading causes, leading use cases for technology. I'm going to give you some advice on how to apply these, and we'll move on from there. One key thing that we always urge customers to think about is most of your facilities have many different types of machines. Everything from small golf carts, which we don't have pictured here, but all the way up to material handling cranes, many forklifts, many bobcats. There's a wide variety of machines in many industrial sites. And it's important that we take a holistic view. We know that you want to protect the material handling operations, but it's not always the case that every technology applies. One size certainly does not fit all. We urge you to think about what type of machine you're applying this technology to, where, how is it used? Is it indoor? Is it outdoor? And then take a look at what are you trying to protect? Are you trying to protect people? Obviously, that's the leading cause. But are you also trying to detect other machines? So are you doing people-to-people detection, people-to-machine detection, machine-to-machine detection? Are you also concerned about damage? Are you concerned about hitting key infrastructure in your plants? There's a lot of times customers come to us and say, the safety is my primary reason, but we'd also like to reduce damage to our machines. We'd also like to reduce in-plant damage. We had a use case last year where we had a multi-million-dollar damage to a facility because a utility pole was knocked in a yard. So what are you trying to protect? And the thing about that is it's not always the same depending on where the operation is in your facility. And then lastly, one thing that we always urge our customers to consider is the environment. Most camera systems aren't designed for heavy industrial use. Now, most systems are designed for over-the-road applications, and there's a plethora of technology that's being pushed into the industrial segment that just is not designed to last. There's high shock and vibration ratings. There's high temperature ratings that all I urge you to look at when you're applying this type of technology. One thing to keep in mind is most over-the-road applications, your cars where most of this technology is being applied, there's shocks, right? They have rubber tires. The overall vibration is not nearly the same as on an industrial forklift that has no shock system, no suspension system. And keep that in mind as you start thinking about what type of technology to apply. We're seeing a wide variety of technologies being applied in the industrial segment. And as I mentioned, most of that is being driven from the commercial sector. A lot of cars, in fact, all cars that are being sold in the US now has to have a backup camera on it. It's just part of the federal mandate. But you're seeing a lot more with blind spot detection systems, backup warning systems, lane departure systems. And all of that technology is now available for the industrial segment. So we're seeing those technologies being applied to forklifts, to little bobcats, to golf carts, to large machines. We're seeing a wide variety of technology being deployed on the industrial floor. And I'm going to briefly talk about each of them for you and give some advice based on what we've seen on how they are applied. Essentially, I broke it down into two groups. We've got non-proximity detection systems, which are your basic camera systems. And we also lump in there wireless camera systems because we're seeing a lot of wireless camera systems being applied in the industrial segment. And then we have proximity detection systems. Basically, we're seeing 4 different technologies being deployed for proximity detection systems. Ultrasonic, radar, vision, and RFID based, and they're priced in that order. So the lowest cost are ultrasonic, and the higher end stuff is vision based and RFID based. So let's jump into each of these technologies and let's talk a little bit about how you can apply them in your facility. Camera systems, very basic, It's the start of your journey. Most of the industrial machines that you have in your facility have blind spots. They have areas where your operators cannot see, and a simple camera system can help alleviate line lifting and increase the performance and safety of your operation. Most of what we're seeing applied are rear view cameras, but there also been a very, in the last couple of years, probably the last year, there's been a lot of these surround view / bird's eye view systems being deployed. These are giving your operators 360-degree view of the systems of their operation. And it's really, really a cool thing on how the manufacturers are stitching these images together. And then we also are seeing a lot of cameras being deployed on cranes. So overhead cranes in your facility are pretty heavy material handlers. And we're seeing a lot more cameras being deployed from the overhead. One thing that I recommend when you're looking at camera systems, and you're going to keep hearing me talk about make sure things are rated for industrial use, we recommend a 20G shock and vibration rating for industrial use. So when you're looking to deploy a camera system, I highly recommend that you look for something that has at least a 20G shock and vibration rating. Also look for something that has high temperature ranges, especially if you've got facilities where you're in and out. And the reason that's important with the high temperature ratings is that if you've got a very warm indoors going to an outdoor facility that's cold, an inexpensive camera system that doesn't have a temperature range that can accommodate that has a tendency to have a condensation, fog up, and you could temporarily have a blind spot, with condensation built up on the camera. So high shock and vibration and high temperature ratings are something that we recommend for the basic camera systems. Now, camera systems are great, but they're only good when your operator's looking at the monitor. So they're a passive system. So these are non-alarming. They're there just to aid in the visibility of your operator. So a camera system is your lowest cost of entry into the world of safety, but it is also your least effective. It's only good when your operator is looking at the monitor. As I mentioned, wireless camera systems are becoming more and more widely used. And the reason that we're having success deploying wireless camera systems is now we can put cameras in places that they haven't been before. On lifting hooks, on stations that a forklift accesses only routinely, and we can wirelessly transmit to that forklift operator cab. We can have wireless trailer systems. So there are many facilities that have trailer jockeys running around their facility, and those cabs may pick up trailer A today, trailer B tomorrow, or trailer A now and trailer B in an hour. In the past, it's been very difficult to link up to camera systems on trailers, but with the advent of new wireless technology, it's very easy to have operator views of many different trailers. And then also I mentioned wireless load view systems. We're seeing wireless cameras basically on hook blocks of cranes and other load view systems where now we can wirelessly transmit that signal not only to the operator cabin, but back to a central processing unit, back to overhead cranes. We're seeing a lot more versatility of the camera systems that use wireless. Something to keep in mind when you're using wireless camera systems is, again, you look for a dedicated wireless transmission systems. A lot of our customers want to put it on plant-wide Ethernet. They want to use plant-wide Wi-Fi, and sure, all of that's attainable and achievable. However, it's not recommended. The bandwidth of these cameras, especially when you get more and more of them involved, has a tendency to bog down plant systems. If you're on a plant Wi-Fi, you could find that your latency, which is delay in signal, would be prohibitive, and make these cameras and their wireless transmissions not worth the time if they're a 3-second delay. So something to keep in mind when wireless is we recommend a dedicated transmitter receiver. Make sure that they're on their own system, especially if they're in critical use applications, and stay away from plant-wide Wi-Fi if at all possible.
Rob, let you take a brief breath. One common application with those wireless crane systems is blind hook applications. So if you have crane applications in your plant or in your facilities, very common application for that is blind hook, correct?
Yeah, absolutely. Yeah, that's where we're seeing a lot of wireless systems deployed these days. Yeah. And these wireless camera systems are just like the other camera systems I just mentioned. They're passive. There's no proximity detection system. They're merely to aid your operators in the presence, to aid their visibility in blind lifting or blind applications. All right, we're going to step up a notch here in our technology and complexity. We're going to talk about our first proximity detection system, and this is the lowest point of entry for proximity detection system. It's an ultrasonic technology. It's very widely deployed on commercial vehicles. In fact, if you have a proximity detection system on your vehicle, it's probably ultrasonic. They're very, very inexpensive, and quite frankly, they're not built for industrial use. We very rarely put these on forklifts or industrial machines just because they're not rated for shock and vibration. And they're also subject to, they need to be clean. They're not subject to dirt and mist and all of that for long periods of time. And what happens is if you have an ultrasonic sensor that's not rated for industrial use, it's going to go off all the time. And what an ultrasonic sensor does is it basically sends out an ultrasonic beam that really has a short range, maybe up to 4 meters, 3-4 meters, 10, 12 feet out. That ultrasonic beam is going to bounce off anything and send a signal back. Then it's going to alarm audibly the operator in the cabin of the vehicle that something is out there. Typically, ultrasonic is just giving an audible alarm to your operators, to inside the cabin, to the presence of something. Typically, you don't know where that is. So if it's mounted in the rear, you could guess that something's in the rear of your vehicle, but you don't know if it's rear right, rear left. And it specifically usually is wired to alleviate some of those concerns, only wired in the motion you're moving. So typically you wire it in reverse for when you're, reversing and so on and so forth. But an ultrasonic sensor is the lowest point of entry into proximity detection. It's going to alert you to the presence of something. It has no smarts in it. It's not going to tell you what is out there. It could be a person, could be an object, could be another vehicle, but it certainly is subject to dirt. If it's covered in mud, it's going to continue to go off. So we're very careful recommending ultrasonic. You see here this photo that we're showing it on a on-the-road vehicle. So if you do have a facility where you do have maybe some maintenance vehicles running through your facility, we would consider recommending ultrasonic for that. But as far as forklifts go and other vehicles, other machines in your plant, we're very, very careful to recommend ultrasonic based in those applications. There is a step up from that. The next technology that we are seeing deployed in the industrial segment is radar-based proximity detection. This is the next step up in proximity detection. You see here, we talk about rear proximity detections, proximity detection, and side proximity detection. Theoretically, you could do 360-degree proximity detection system with both ultrasonic and both radar. But again, just like ultrasonic, radar is sending a signal out from each sensor. It's going to bounce off anything out there and receive back a signal saying something is out there. So they are not going to differentiate between a person, another machine, or an object. It's going to alarm to the presence of something out there and alert your operator. Typically, we're putting radar in conjunction with cameras. So you see here on the picture on the left. So typically, unlike ultrasonic, radar is a visual based with an audible warning. So it's a step up from the ultrasonic. Radar is a lot stronger of a signal. Typical radar systems can go 50, 60 feet. So they're very strong and powerful. And we do have experience with them in industrial facilities where there's mud, dirt, and they work very well because they're have much more power. So if you have a larger vehicle that's indoors, outdoors, and you want a proximity detection system, we would recommend probably a radar based. Now, I say probably because radar is very strong and it doesn't differentiate. So the biggest complaint we get against radar is that it goes off too much. And that's the last thing we want to do. There's a lot of studies about all this technology. There's white papers written about alarm fatigue. And the last thing we want to do is put this system in and have it go off too much. And that's the case, it's going to number one, drive your operators crazy. Number two, it's going to be white noise. Then they're going to ignore it and it's going to give false sense of security. So very, very powerful system is a radar, but we're very careful in deploying it just because it has a tendency to be so powerful that it goes off too much. Now we can adjust the ranges with radar, and we can wire it into motion only, so rear, only turn it on when you're turning for blind spot radar. So there are instances that you can protect it, but again, in tight areas, a paper mill, a warehouse, a roofing place where you have tight corridors, radar is probably going to go off too much and not be nearly as effective as you had hoped. Let's step up from radar. Again, keep in mind, we're working our way up the food chain here. And when I mean working our way up the food chain, we're working our way up in price. But during the last couple of years, there's been a few, not many, of vision-based pedestrian detection systems being deployed in industrial. And I must say, as we work our way up the food chain, you're going to find fewer and fewer vendors on the marketplace who are doing this. So if you started ultrasonic and Google ultrasonic, you're going to get page upon page upon page of people offering ultrasonic sensors. If you do radar-based proximity detection system, you're going to get less, but you're still probably going to get page and page. Google pedestrian detection, and you're going to get far, far less vendors, especially pedestrian detection for industrial machines. There's very few people who are doing this in the world right now, and it's a very, very effective system. So essentially what's happening is they have a stereoscopic sensor, which is a 3D dual sensor camera system that is tied to a processing unit. And since it is a camera, we are putting the images, as you can see here in the upper right, we are putting the images as a standard basic camera. So it can be used as a camera for viewing as well. But the key here is this is smart enough to alarm in proximity only if there's objects or only if there's people. So we're stepping up from the radar in that we're observing our area. We're teaching this camera what a person is. We've taught it what an object is, and we're taught it, and it's taught to differentiate between the difference. So what customers can do is they can set up zones of vision that they can alarm only if appropriate. And something key here is that this vision system has to see, right? It's vision. So we can't have loads in the way. We can't have massive forklifts in the way. But if you've got clear vision, you can set up distinct zones. So what we're showing here is in the yellow is a collision zone. So we're going to alarm your operator to the presence of everything: a utility pole, a steel coil, a paper feeding machine, a person. We're going to alarm that operator to something, that something's in the area. But then we're going to also have a danger zone. We're only going to alarm if there's pedestrians. You see the orange zone here. So this camera is smart enough to ignore objects in that danger zone. So we're going to ignore everything else and only tell your operator that there's a person there. And why is this important? This is a great tool to use in high pedestrian areas, high traffic areas where you just want to know if there's a pedestrian down there, especially in tight environments. This system does not go off very much, which your operators love, but they know that they can they'll be alarmed if there's a pedestrian behind them. These vision-based systems have smaller detection zones, usually about a maximum 120 degrees out to maybe 20, 30 feet. This particular graphic here is showing only protection out to 6 meters, which is just around 20 feet. So they have limited protection zones and they have to see, but they're very, very efficient in managing your alarms. Next slide is an example of a large piece of equipment, but these cameras are very easy to configure, easy point, click, and drag, and customizable on the zone. Obviously, many of you may not have a large piece of equipment like this, but you can see in the red zone here on the picture is where we're detecting all the objects, and in the yellow zone, we're detecting pedestrians only. So this particular customer wanted a very small object zone and a very large pedestrian zone. So these smart vision-based camera systems are coming more and more. We're putting them on a lot of forklifts now. We have major corporations across the US who are specifying these as a step up from a standard backup camera. But they are typically a large investment. You can typically get a backup camera system for less than $1,000, and these systems start at $4,000 to $5,000. So it's a significant upgrade and a significant investment, but it gives ultimate protection as far as pedestrians go.
So Rob, one quick point I did want to mention. So when it comes to these vision-based systems, obviously you need to, that is the one caveat, it does need to see, but it's difficult to get 360 degrees of protection with these unless you have cameras on all sides of the vehicle, correct?
That's correct. If you had an application where you really wanted 360-degree protection, it's very difficult for the vision-based system to do so. It's possible, but it gets quite costly, Andrew, putting this many sensors around a vehicle.
And what is the degrees of angle typically on one camera system like this?
Yeah, most of these systems, because they have two cameras, are limited to maximum about 120-degree field of view, which is pretty significant, but it's not nearly some of the camera systems have 170, and upwards of 140. So 120 degrees max field of view.
Very good, thank you.
Mm-hmm. The last technology that I was going to talk about that we're seeing deployed is RFID-based proximity detection systems. And again, Google RFID-based proximity detection systems, you're going to see a handful of companies doing this in the world. But these are the most complete systems on the market. They are allowing customers to do much more than just machine to people or machine to machine. With these RFID-based systems, you can track operators, you can access control, you can do crane to people, machines. So it's a very, very flexible and powerful system, these RFID-based proximity detection systems. And essentially what they are it's a marriage of a sensor. You can see the sensors here on the upper right of the screen. And those sensors interact with an RFID tag that needs to be worn by people or machines. And these RFID tags are the way that we identify that something's out there. And when an RFID tag comes in contact with the sensor, we're alarming the operator to the presence of someone in that vicinity. You see here this little display here that's usually put in the operator cabin. This display is showing some red lines front left and behind, so we can tell your operator where the object is and what it is. We have the ability to differentiate whether it's long distance warning, short range warning, or machine to machine. So we have many different visual warnings for your operators, and he'll understand that it's a person, an object, or a thing, and whether they're long distance or short range. So RFID-based is the most effective for 360-degree protection. The way that these sensors work, they use microwaves, and it's a very encompassing and powerful wave that kind of acts like an amoeba. We've used microwaves to see around corners, so we can do blind corner cross warnings. And microwave and these RFID-based systems are the most effective way to give you 360-degree protection. But the biggest complaint we get against RFID systems is that everyone needs to be tagged. So it is a common complaint against RFID-based systems, is the inability or concern of customers to manage the tags. Everyone on the floor has to have a tag. Every machine has to have a tag. Every key asset has to be tagged that you want to alarm. So it is perhaps a cumbersome task, but we are, our company is deploying this system in many cases across the USA. So it can be done. I don't want to dissuade you, but the common complaint we get against RFID-based is the tag management.
And that is something, Rob, that it's just an investment on the team and the team members and whoever's facilitating the PPE of the workspace. There's a lot of different ways that they can wear tags via hard hats or lanyards. So a lot of different form factors, in regards to that, correct?
Yeah, exactly. Yeah. Belt clips on your hard hat, in your pocket, a variety of different ways. But there's no doubt about it. The tag management is something that I urge you all to think about as you're looking at proximity detection using RFID. And I want to move through this as we keep moving here. Another powerful thing about microwave-based RFID is it gives you the ability to do some geofencing and indoor zoning. If you mount sensors in key places in your facility, those sensors can communicate with the machines on the ground and create safe zones or other objects. So in this slide here, we're showing a graphic in the red. We're automatically turning the lights on of the forklift. In the yellow, we're actually limiting the speed of the forklift to less than 5 miles an hour. In the blue section, we're making sure the forks are down. So we're automatically lowering the forks. So these smarter systems, the RFID-based system, the smart system, the vision-based system, they do have the ability to interact with machine control. That's a topic for a whole nother webinar, the machine control and the interface, so we won't get into it. But just know that these smarter systems do have the capability to communicate and do something with your forklift. It gets quite complicated, but it's not something that is unattainable. It's something that you can do with coordination with us and your forklift dealers. And then last but not least, before we get into some quick application photos, another trend that we're seeing in these two smart systems, the vision-based and RFID-based systems, is that they're collecting data. So they're starting to log all these interactions, whether it be vision-based or RFID-based. The data is being stored on these machines. And we have customers who are getting this data off these machines and using them for metrics and measuring, and using the data as a way to measure the improvement in your process. So, we can show you detections by day, we can show you detections by speed, We can perform heat maps. You know, obviously the one on the right here is showing a heat map of an outdoor quarry, but the data that's coming off these machines is getting more and more used. In fact, I just had a conversation with a customer yesterday, a major customer, who said data is critical. We have to have a system that has data. And this data is a way to do some system improvements. This is just an outdoor quarry, of course, but the same case study could be made indoors. And what we did here in this was we're just showing the first slide here is where all the interactions were. Using that data and using some quality controls, after 1 month, they made some changes, and you can see how the detections have minimized. So they're minimizing their exposure to risk by changing the way that their operation is. And then after 2 months, with some simple changes in their traffic patterns, you see what happens in the last slide. So in just 6 months, using data and these smart systems, they went from all the potential for danger in the first slide to just 2 potential instances. So this data is becoming really, really important, and it's available on all these smart systems. So as you look for proximity detection systems that have intelligence, such as the vision systems and RFID systems, I highly recommend you look for a system that collects data and gives you multiple ways to get this data off. Most of them have 3 different ways. You can just simply have an SD card or USB coming off the machine to do data collection after an incident. Or if you wanted to upgrade, you could do some Wi-Fi collection or even some 4G. So you can have constant communication with the machines to get this data. So, you know, obviously it's a cost, it's an investment, it's an upgrade. But as you start thinking about proximity detection systems on your journey toward improving the safety of your facility, keep in mind that data is something that's available out there. In an effort for time, I'm running a bit over here, so we're just going to dive into some quick application photos. I mentioned the rear view of camera systems for forklifts. You know, this is a quick picture of what customers are hoping that they can help their operators with. Increasing the ergonomics and eliminate him looking around, a quick rear view from a standard camera system. Another system we're deploying that is very popular right now is Fork View. This particular camera is mounted mid-mast. If you look closely, it's giving your operator a view of his mast. So it's a wonderful view, especially for overhead lifting applications. It improves the safety, but also the efficiency. It helps your operator nail his spot quicker than he could trying to look up overhead. This is a cool example that we like to show. This is on a very, very large piece of equipment. But the motivation here was to mount this camera on this machine. You see it circled here, a little eyeball camera. And what they wanted to do was protect this middle tire. That tire costs about $15,000. And they have a blind spot there, and that camera gets nicked very often. So I'm sure many of you don't have cameras machines this large, but this is a you know, under $1,000 camera system that they mounted to try to save a $15,000 tire to help their operator in this instance. So a very cool application. And I mentioned bird's eye. Look at this image. This is something that a supplier from Germany is offering. It's called a Mobile Vicinity Scout. It's a 360-degree view. And for those of you who don't know, that this is a Lindy forklift, but this would give your operator a bird's eye view of what's happening around him. And it's a really, really cool technology that if you want more information on, you know, the way that this works and the way that this is put together is like I said, a topic for another discussion, but we can get into that. These are becoming more and more popular. These bird's eye cameras, they're available on many new models of cars, and believe it or not, we can deploy them on industrial machines. Radar-based systems. You saw on our earlier slide here that it's a radar sensor coupled with a camera. We really don't deploy these on small forklifts, so it's doable, But these pictures are, you know, on large pieces of equipment. You notice how dirty this is? Keep in mind that I mentioned that radar works great in dirty environments, and believe me, this it doesn't look like this now. It's just as covered in mud as the rest of the machine. Again, radar on larger pieces of equipment. This is a rear radar system, and a typical application for that. RFID-based proximity detection systems. So you heard me mention that it all starts with the sensors. These sensors typically are mounted strategically around forklifts. This particular Toyota has 2 mounted in the front and 1 mounted in the back, and it's giving 360-degree protection. This is a little different shot, but the back of it has 1 sensor, and the display for the operator is mounted up in plain view, so he can see when it audibly alerts him. He can see where the danger is. So typically on a forklift that many of you have, we're putting 3 sensors. A larger forklift we could put 4, but a typical setup would be 2 sensors in the front around the mast and 1 in the rear. Same sort of thing on RFID based on larger machines. Even large haul trucks are using RFID based proximity detection systems. Obviously this bad boy has 4 sensors, 2 in the front, 2 in the rear. And then the vision-based systems that I talked about, the smart cameras, are typically mounted in rear because we don't do a lot of forward-facing with the vision-based systems because they have to see. So what I mean by that is if you have a load or an attachment in the front of your machine, a vision-based system isn't going to be able to see around that, and sorry about that. It is a problem. So vision-based. We do a lot of rear-facing. Here's a typical example on a forklift. And one thing I want to point out that the vision-based and the RFID-based, if I haven't met it, they each have a controller. They each have a processor that needs to be mounted on board that system. So you see here in this photo, the sensor mounted on the top of the cab there. And I also circled the processor. So it's something to consider when you're looking at mounting these systems. Not only do you need sensor heads, but you're going to need space for the processors. So if you have an indoor-outdoor piece of equipment, make sure that your processors are rated for indoor-outdoors. As you look across the spectrum, there are a few companies offering these systems that don't offer weatherproof processors. We highly recommend that you get one that's rated for high shock and vibration, rated for indoor-outdoor use, because a lot of your forklifts have space limitations, and these processors can't always be mounted in a environmentally controlled area. So look for processors and sensors that are high shock and vibration rated and high temperature extremes. I mentioned that the vision-based has to see, and Andrew brought up the question of 120 degrees. Sometimes on larger pieces of equipment, 120 degrees just isn't big enough. So it's not uncommon to mount more than 1 vision system. And in fact, the larger machines, how about 3 sensors? This is a big telehandler piece of equipment. Many of you may not ever have seen these or have one, but this particular guy's got 3 vision-based systems on there.
And Rob, those multiple images can then be stitched together on a monitor in the cab, right?
That's correct. Yeah, very similar to that. And they alarm. You can wire them to be independent alarming or one alarm, all alarm. They have smarts to them on how they alert the operator. All right. And then last but not least, not the best photo in the world, but I just wanted to show you that it's not uncommon, and it's becoming more and more common for customers to combine systems. So this particular customer felt that they needed just a simple, inexpensive camera to aid their operator. They've got 2 cameras here. They've got a left view and a right view. That's simply to aid him in the blind spots. But then in the middle here, I keep doing that, sorry. In the middle here, they've got a proximity detection system that's giving him 360-degree protection for people. So this is a tag-based system. So this particular machine, it's a very large machine, But they've got both. They want to help their operator with blind spots, and they also want to make sure that pedestrians are safe in the area. And then last but not least, I don't want to spend any time on this, but we're seeing a lot of coordination with other accessories. Projector systems are very popular right now. We could, for example, what's a projector system? Meaning we could put sensors in your environment that detect a forklift coming. We can project a sign down on the ground that says danger, forklift coming. We could do the same for doors, indoor, outdoor, machines coming in from outdoors. We can project or put a blue light on the floor and let people know that something's coming. Halo systems are these red blue lights that are going around forklifts. Driver fatigue systems, impact sensors, all of this technology we're seeing deployed on regular everyday forklifts. So if you can dream it up, there's a vendor out there for it, and you'll see it more and more. Just as a point of reference, here are some of the partners that we have that have contributed to all of these photos, and they're accessible on our website. So I've gone over my time, Andrew. I just want to end with a big thank you to everyone and open it up to any questions if there are any.